Okay, welcome back to Exponential Logarithms Part 2. Now today what I'm going to do is I'm going to use some problems to demonstrate the different properties that we learned from the first video, which are the product rule, the quotient rule, and the power rule. So first, what I want you all to think about is, on the first problem, square root. What does square root really mean? Now, most of us know, yes, it is 5. But why is it 5? Well, in our previous video, I showed us that the square root means there's really a 2 here. So if I break down the 5 and the 5, that 2 means if I have a pair of 5s, I bring one out. That's why it's 5. But there is a however here. Is our calculators do not read this. Technically, it could be 5, which are both negative, because negative 5 times negative 5 is 25. But we're going to use the positive end of it. So now, as far as our exponents are concerned, if I take 25, which is our base, our exponent now is 1/2, because from our previous lesson, if you have a radical symbol with a number, you just make it a fraction. It's 1/2. Now, most of our calculators, you could just put 25 raised to the 1/2, but some of us, we may have to, if it doesn't automatically put it in the exponent form, use parentheses. Now, when you put 25 raised to the 1/2, you will get 5. Now, let's look at this cubed root of 125. Okay, 5 goes into 125, 25 times. I cannot do anything with the 5. However, the 25 can be broken down into 5 and 5. Now, this cubed root means when I see 3 of a kind, I've got 1 5, 2 5s, and 3 5s. That means my answer is 5, because you got a pair or 3 of a kind. Now, how you would put this, like in your calculator, you could say 125, the raised symbol, in parentheses 1/3, if your calculator does not put it in the exponential form, and then you should get 5. Now I'm going to start using our properties that we have learned in our previous lesson. Now notice 3 and 4. They look the same, but they're not the same. So what I'm going to do is I'm going to actually demonstrate number 4, because what I tend to get is students will think of number 3 and they will write it like 4, but this is not the case. That's why I want to go over 4 first. So 4, I want you to think about, okay, I've got a fraction, that means division. Division is quotient, the quotient rule. What do we do with the quotient rule to expand or to separate the fraction? We subtract. So we say log 7, subtract. Now notice the 5 will also get the log, minus log 5. Now number 3 is a little bit different because we don't have the fraction 7/5. What we have is log 7 divided by 5. So I want you to think about something. There is an understood 1 in front of the log 7. So technically that could be written as 1/5 log 7. Now what I'm going to do is I'm going to reversal, and I'm going to put the 1/5 back with the 7. So when I do this, I get log 7 to the 1/5. So this comes out to be log the 5th root of 7. What happens in number 5? let's say you have log and then 7 times 8 to the 5th. So you need to identify what properties we're using. Well, I see a multiplication, so I know where I'm going to use the product rule. That's an exponent, so I do know that we're going to use the power rule. So first what I'm going to do is I'm going to separate them by the product rule. Log 7 plus log 8 to the 5th. And then what I want to do is I'm going to, cannot do anything with the log 7, but what I can do is drop the 5 down, make that 5 log 8. Now number 6. Number 6, I see m over n, which is a fraction. Fractions are division. Divisions mean quotient rule. Then I've got this 3 that is the power rule. So there's several ways we can do this. I'm going to choose to use the power rule first. I'm going to put that 3 right in front. And then my final step is I got 3 log. I'm going to separate the m and n by, since I'm using the quotient rule, I'm going to subtract it. So 3 log m minus 3 log n. Next, I have log 7 times the 5th root of 8. So what I want to do on this one is I see a multiplication symbol. That's the product rule. I see this 5th root, that means exponent. So first of all, I'm going to separate by saying log 7. Since it's multiplying, I'm going to add. I cannot do anything with the 7, log 7. But what I can do is I can make that 8 to have an exponent by using that 5th root and make it a 5th, 1/5. Finally, I can bring that 1/5 down. I still have log 7 plus 1/5 log 8. Finally, let's just say I have log the 8th m times n times o times p. Like I said, there's several ways we can approach this. I'm going to use the power rule, and I'm going to put the m, n, o, p in parentheses. That 8th root means I'm going to raise it to the 1/8 power. Then I'm going to drop the 1/8 in front. And I've got 1/8 log m, n, o, p. And then in a way we can distribute that 1/8 log to everything in parentheses. I'm going to say 1/8 log m plus 1/8 log n plus 1/8 log o plus 1/8 log p. So I hope this helped. This concludes part 2 of my video series of exponential and logarithms. Thank you for listening.